let's make another model, a Python model, on the coronavirus uh, exponential growth. And in particular, everyone talks about this flattening the curve. Let's model a flattening of the curve. So you might want to go back and look at my last video, but in that I made this thing. So let's just run this. I'm going to show you what it does. This says that the number of people that get infected depend on two things. It depends on some rate, and then there's a factor that decreases as more and more people get infected, because you can only get so many people infected. And you get a graph like this, and this matches the Chinese data for their infection fairly well, so we're going to start with that. So let's say that I have another population. It's exactly the same, but they're doing something. They're washing their hands, they're social distancing or something, and they're going to decrease this infection rate. So let's say I have a different population where A2 is equal to 0.2. Okay, so it's a little bit lower. So we need another group, N2 equals 1. They have the same maximum number. I don't need that. So all I need to do is copy this and change those to 2s. They have the same max, so I don't need to change that. And then I need to plot it. I don't know why I have all these spaces in there. And then let's plot f2.plot t into, I think that should work. Save it. And I'll give you the link to this. Okay, so run it. Okay, so that looks pretty good. Actually, let's make it a little bit closer. 0.3. Okay, so that's good. So here you see the one. They still have the same number of people get infected. They still get to 80,000. Okay, but in this other group, it takes them longer to get infected, and this is what we think about when we talk about flattening the curve. And it's hard to see, because really you want to think about this. We don't want everyone to go to the doctor at the same time. So we want to really get the rate of people infected, the slope of this line. So the slope of this line down here is 0, the slope up here is 0, but right here, this line is steeper than that a little bit, but I want to plot it. So how do you plot a derivative with numerical data? Because I'm just calculating every value based on the previous value. This is not a function. I can't take the derivative, but I can essentially take the derivative. If I look at the slope between the current point, the current n value, and that point before it, and then I divide by the time interval, that is the slope. Okay, so let's do this. I'm going to say n, I don't know why it's like that, n old equals n. Okay, so this says that I'm taking a placeholder. I'm saving the last data point. And then when I calculate the new data point, I can refer to the old data point. Okay, and I'm just going to calculate one slope first. So say now r is the rate. It's going to be equal to the new data point, which is n, minus the old one, divided by the time interval, which I know, dt. So this is the change in y over the change in x, if you want to think of it. Okay, so that's the slope using the old data point. So now let's turn off F2, and let's see if we can plot this. See if it works. There you go. So this says up here, I'm getting a maximum of 8,000 per, I guess, days, right? Infected. But that's the total number. And then eventually there's no one infected per day. These are the people that enter the rate that people are entering the hospital, assuming. Okay. They don't all go to the hospital. Okay. So now let's change this. This is now the infection rate. Yeah, that's fine. Okay, and now let's do the same thing for N2. So I'm going to go down here. N2 old equals N2. And then R2 equals, that's copied over here. It's going to be N2 minus N2 old divided by dt. And now I can plot that. And this will be R2. Okay, so if you found the area under these two curves, they're the same. Okay, but this one, since they have a lower slope, it doesn't have as high of a peak. This is a flattened curve. It's spread out more. So you only get up to 6,000 people per day entering the hospital. This has 8,000 people today. Let's change this to, let's say, 0.2 for the infection rate. And you see, actually I need to increase the time. 70, let's say. There you go. So now I'm down to 4,000 people. And this is that famous picture that you see of flattening the curve. We built it in Python. So once you kind of build something, then you really start to understand it, right? So this is just basic numerical models, and I'm thinking I'm just going to end there. I hope you enjoy this. I hope you don't enjoy this. I hope you learn something, okay? Because no one's enjoying this. Trust me. Okay. I'll talk to you guys later. Bye.